The next question we can ask, though, is how is reality created from the field? Most quantum physicists agree that it is a very similar process to the creation of a hologram. In other words, the universe we see is a holographic universe.
When we look at some of the modern scientific views of reality that have tried to get down to the nitty-gritty, we see that at its ultimate level, say in M theory or string theory, that reality is not solid, it's mostly empty space, and whatever solidity it has seems more to resemble a hologram picture rather than material, harsh, solid reality.
So to understand the holographic universe, we have to understand what a hologram is and how it is created. The simple definition, according to Michael Talbot in The Holographic Universe, is that a hologram is a virtual image, an image that appears to be where it is not. In other words, a hologram is an image that is not real. The technical definition from the Merriam-Webster Dictionary is that a hologram is a three-dimensional image reproduced from a two-dimensional pattern of interference produced by a split coherent beam of radiation as a laser. Please don't panic. I'm going to explain that technical definition very simply. Let's look at how a hologram is made. It is actually a two-step process. First, we shoot a laser beam out of a laser gun, and then we immediately split that laser beam into two beams. One of the beams, called the reference beam, makes its way and eventually hits a sensitive holographic plate or film. This is like the film we used to have in our cameras before digital photography. The other half of the laser beam hits an object first, in this case an apple, and then hits the holographic plate. When these two parts of the original laser beam come back together at the holographic plate, they interfere with each other, just like the waves did in our double-slit experiment, and they form an interference pattern on the holographic plate. If you look at the holographic plate at this point, you cannot see the apple. All you can see is the interference pattern, which looks like a bunch of waves. This is step one of creating a hologram. Remember those 3D pictures that were such a fad in the 1990s, which looked just like a bunch of meaningless waves? But if you refocused your eyes, an image would pop out for you to see. So, for our hologram, we now need a step 2 to see the image of the apple. In step 2, we focus another laser beam on the holographic plate where our apple sits in wave form, and if we get just the right angle, out pops the apple, looking very real and very solid.
You might wonder what I'm holding in my hands here. Looks like a black picture, but if I shine a light on it at a certain angle, watch what happens. It's a picture, it's a hologram. Now this isn't one of those cheapskate holograms, this is the real deal. Watch what happens when I turn it. We have genuine three-dimensionality there, okay? There's no denying that. In fact, one of the things that the camera doesn't really pick up is that the image actually comes right out of the picture to the human eye. I mean, if I place my finger here, in terms of my depth perception, that's as if I'm touching its nose, and yet I can move that far back into it. There's nothing there, and yet it appears to be that I could literally actually stroke it. There's no denying that there's real three-dimensionality there. This is a particularly good one because it's got these big gnashers, and if I try to move it a little closer to get you a real good look inside the mouth here, you can see very, very clearly if you look at the teeth in relation to the tongue behind it, there's genuine movement here. You are actually getting to see behind things. Yeah. So that's the wonders of the hologram. And yet there it is. It's in a completely two-dimensional space. It doesn't really exist, even though my eyes tell me that it does exist.
I'd like you to see a few examples of just how far we've come in our holographic technology over the past